Folate's quiet influence on hormonal health is a fascinating and rarely discussed dimension of its nutritional power, revealing how this essential B vitamin extends its reach far beyond DNA synthesis or anemia prevention to the subtle world of hormone balance. While hormones like estrogen and progesterone orchestrate many aspects of reproductive and metabolic health, folate indirectly supports their metabolism and clearance, helping to create a more stable internal environment and potentially lowering the risk of hormone-related conditions. At the core of this connection is folate's central role in methylation, the biochemical process of adding a methyl group to molecules, which the liver uses in phase 2 detoxification pathways to neutralize and remove excess or spent hormones. Estrogen, in particular, undergoes methylation as part of its metabolism. After it's used by tissues, the body must transform it into water-soluble forms that can be excreted via urine or bile. If methylation is inefficient, estrogen metabolites can build up or linger, some of which are more reactive and may contribute to DNA damage or chronic inflammation in estrogen-sensitive tissues like the uterus, ovaries, and breasts. By providing the methyl groups needed for these clearance pathways, folate supports efficient estrogen metabolism and helps maintain a healthy balance between estrogen and progesterone. This balancing act is especially important in conditions characterized by estrogen dominance or dysregulated estrogen metabolism, such as polycystic ovary syndrome, PCOS, or endometriosis. In PCOS, women often experience irregular cycles and elevated androgens, but they can also have imbalanced estrogen levels that exacerbate symptoms like heavy or erratic periods. Optimizing folate status may indirectly support healthier menstrual patterns by improving methylation-dependent detoxification of estrogens, reducing the hormonal fluctuations that contribute to cycle irregularities. In endometriosis, excess estrogen can fuel the growth of endometrial tissue outside the uterus, worsening pain and inflammation. Some emerging research and clinical observations suggest that supporting methylation, including through sufficient folate, may help reduce the hormonal drivers of endometrial lesion growth, offering a potential adjunctive strategy to traditional treatments like hormonal contraceptives or surgery. Adding another intriguing layer, folate's role in regulating homocysteine may influence fertility outcomes in women with PCOS, who often have elevated homocysteine levels associated with poor egg quality, impaired implantation, or early pregnancy loss. By keeping homocysteine in check, folate could indirectly support ovarian health and reproductive success. Beyond estrogen, folate-driven methylation helps regulate the expression of hormone receptors, proteins that determine how tissues respond to hormonal signals. Balanced receptor expression is crucial not only for reproductive health, but also for mood, metabolism, and immune function, all of which are intimately tied to hormonal regulation. Altogether, these insights reveal folate as a quiet but vital ally in the complex symphony of hormones, helping to metabolize estrogens efficiently, balance reproductive cycles, and protect tissues from the potentially harmful effects of unprocessed hormone metabolites. By prioritizing optimal folate intake through foods like leafy greens, legumes, and fortified grains, or considering active folate supplements like L-methylfolate when needed, we can better support the hormonal harmony that underlies everything from menstrual regularity and fertility to long-term risks of hormone-related disorders like PCOS, endometriosis, or even estrogen-sensitive cancers. In doing so, we uncover yet another layer of folate's profound and often hidden value for lifelong health.